We've all heard that famous story of Newton getting hit on the head with an apple, but let's look at the physics that he produced from this observation. Newton calculated that the gravitational force acting between two objects was directly proportional to the products of their two masses. He also found out that the gravitational force was inversely proportional to the distance between those two objects squared. So, with these two pieces of information, he could come up with the fact that the gravitational force is directly proportional to the products of these two masses over the distance squared. And remember that we can change the directly proportional sign to an equal sign simply by adding a constant. So Newton came up with the equation F is equal to minus g m1 m2 over r squared. Now m1 and m2 represents the mass of the two objects, r represents the distance between the two objects, and g is the gravitational constant, and it has a value of around 6.67 times 10 to the minus 11. Now this number is very small because the gravitational force is much weaker than all the other three fundamental forces. So let's look at the gravitational force exerted by the Earth when a human is standing on the surface. Now the radius of the Earth has a value of roughly 6.37 times 10 to the 6 meters, and the mass of the Earth is equal to 6 times 10 to the 24 kilograms. And let's assume that our hypothetical human has a mass of around 70 kilos. Well, the force between these two bodies is going to be equal to minus g times 6 times 10 to the 24 times 70 over the radius of the Earth squared, which in this case is going to be 6.37 times 10 to the 6 squared. And that's roughly equal to minus 691 newtons. Now let's say you were to jump off the surface of the Earth. Now you can evidently feel your weight pulling you back down to the Earth. But we know that from Newton's third law that the force exerted on your body is also equal to the force exerted on the Earth. So as you jumped from the Earth's surface, and I understand that this is in no way, shape, or form a diagram to scale, you would experience a force of magnitude W standing for your weight, pulling you back towards the Earth. And the Earth would also experience the exact same force. But the reason why you move towards the Earth and the Earth doesn't move towards you is that the Earth is much heavier. We know that from Newton's second law that force is equal to mass times acceleration, where the acceleration of the person is going to be equal to weight over m, and the acceleration of the Earth is going to be equal to weight over the mass of the Earth. And the mass of the Earth is much bigger than the mass of a human, so the acceleration of this Earth is going to be almost negligible. The Earth simply won't move because it's so much bigger. But one thing you need to understand is that the force exerted on both bodies is actually the same. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.